Manikan, can you explain business
Yeah.
intelligence role?
Yeah. Go ahead, Subrat.
Yeah, can you explain about this business intelligence role?
Yeah. I'm getting there. Yeah.
Okay.
Right. So when we talk about typical data engineering pipeline, right? I know let's forget about data engineering pipeline. I'll just give one small quick sneak peek on how like our industry works, like the whole IT industry. So suppose we have some business here, right? So what do they want? They need some place where the customers can interact with them and buy their product or services, right? So most of our generation, we tend to use digital services, right? Through apps, okay, through websites, and through chatbots these days, right? So this is all our customer facing applications, okay, facing apps, customer facing applications basically. Not the same apps, but what I mean is customer facing app. So we collect like their interactions and store it in a database, okay, DB, right? Meanwhile, we also have partners or different people where within the organization and external to us where they will send us data as well, right? We will again store them in databases or we will store them in files or something like that. So this is where the first line of actions will start. Once we have this data, to do this we will for these apps we will require a UI and we will require a backend application, right? So this is where we see full stack engineers or all of these guys working. So once they hand off the data here, right? So which is what these whatever you are seeing here, right? So this is what they develop basically. This is where these full stack guys, UI, UX people will stay, and business leaders, everyone will be working with them to create this. Once they have created it, we as data engineers and data people will start our work in extracting the data, slicing, dicing, and enriching the data. Slicing, dicing means like get only the data that we want, and the next thing is we want to enrich the data. Suppose we have marketing data and sales data, right? So we can combine the data in a format where you know the information is readily accessible for us to, let's say, like marketing attribution or a campaign attribution. So for this campaign we have seen some sales. So was this a boom or bust for this campaign? So like that, we need this data. As enterprises need this data, we will create these systems to extract the value out of it, right? So now once we were handed off the data, what the expectation of business is to give us information rather than just raw data, right? Be it through BI dashboards, be it through reporting, be it through machine learning, algorithms where it can say, okay, you are wasting a lot of money on this product, or a lot of money on these customers, right? So this is all required by your businesses to improve their efficiency and to explore newer opportunities, or to discard any opportunities that are currently being done or currently not good. So now, when it comes to data roles, what are roles we see here? Okay. The first and main role we see here is data analyst. Okay. A lot of people think data analyst is just writing SQL, which is for the most part correct. But every data role is a data analyst role, because we need to see what the data represents in every single stage, and we need to understand what's the uh, you know reason behind how it is structured, or what are the results that it is yielding. So that is very important. Whether you are a data engineer who builds pipelines, whether you are data scientist who builds, machine learning algorithms, whether you are a BI, business intelligence, who builds dashboards, you need to understand the data first. That is your primary requirement. Nothing can get past, that requirement. So every data role is a data analyst role, or it has data analyst role characteristics. That means you need to write SQL, you need to understand data, and you need to provide value whoever is looking for that particular data, or who is trying to extract value out of the data, right? You need to understand the business aspects as well as the data. Any doubts? Okay, so I'll take that as a no. And now when we talk about roles and this one, right, these are broad roles. These are not like any company specific roles. A lot of the times, what happens is, data engineer becomes someone like this one, data platform analyst, some weird role names that the companies give. But in general, when we talk about standardized roles, right, this is what data industry has come up with basically. So data engineer is basically one that builds pipelines and bring the data, right? Builds pipelines and brings the data into our data warehouse or data lake, basically, right? So data scientist is the one that analyzes the data. Okay, they will build machine learning models. They will build reports. They will build. They will try to identify the best algorithm that works for the data, and they will work with data engineers to get the data set in a certain format, right? This is what data scientist does. Business intelligence, these guys are, this is like your standard ML, AI roles, right? They deal with building algorithms, or like building algos, or um, yeah, building algorithms for the most part. And this is generalization, by the way. I'm not like trying to like deeply go into what this role does, but on a general note, this is what they are a task to do. Business intelligence is where you want a business guy. Okay, you want a business guy who has business knowledge, right? And they will try to create a reporting through a BI tool, right? Business intelligence tool, which is your Power BI, right? Power BI or Click or Tableau, all of these. So what is this business knowledge here? Suppose um, your upper management needs a lot of insights into your business, and they have certain ways to track these metrics and track these behave track these goals in your business. So that will be communicated to a team like data analysts and business intelligence people. They will break down into metrics, and they will break down into reporting. So that reporting is continuously created and evolved in this Power BI, or any BI tools. Basically, BI means business intelligence. So this is what is business intelligence. Let's say I want to track my revenue over last couple of years, and I want to check what is that is one report basically. And I want to check what is my year on year growth. So am I growing or am I declining? So these are the business definitions, but how do you convert that into data specific requirements, and how do you showcase them? So this is the role of business intelligence, where they will take the business goals, digest them, and break them down into metrics that they can create and track using data in BI tools. Is that definition clear?
Yeah.
Okay, cool. Now, these are broader roles in data industry. They all have their own way of doing things, and they have their own goals. So as I said, data engineer, they will like create data pipelines, and data scientists, they will create ML models. They will create like very specific niche data sets where they can identify insights or unlock insights in their data. And business intelligence engineer, people where they use business goals, knowledge, everything, and put it into a standardized format in this one. So these are like this one. Every data role is an analyst role. If you don't know about how to decipher the data, then it's going to be tough, is what I'm trying to say. That's why I've put a Venn diagram here and then said, okay, business data analyst lives here. Like every role is a data analyst role to begin with. Okay. So you might have had some idea when you are working with data, right? Like every time you have to like give some update to anyone, quote unquote update, right? It is going to be definitely like uh, on you to verify the data. To verify it, either you write SQL queries, either you write some Python test cases, see that okay, the data is up to the mark or not, or are you seeing any weird patterns. So that is like most of the mm, most standard definition or most standard work that a data analyst does, apart from a lot of things that they do. This is the main thing that they like that a data analyst needs to do on a day-to-day basis. Okay. So now that we know about typical data engineering pipeline, what it does, our roles in the industry, where do we fit in, as different roles in the industry. Now we will understand what is the future of all of this, right? So before we just jump into the future, right, we just have to understand some principles here. The reason why I put here is that the reason why I've put this particular diagram is this is really important to know uh, what is going on in the industry rather than what would happen in the future, because every single aspect of data is dependent on this. Whether you bring Gen AI, whether you bring chatbots, whether you bring anything like LLMs or anything, right? This will not change, or some aspects might get standardized more, but this will not change. Again, this is from a book called The Fundamentals of Data Engineering by Matt Housley and Joe Rees. This is a fantastic book, and the whole book discusses on this topic at length. The whatever you are seeing in this diagram at length. So you guys have to read that book. It's a phenomenal book. I'll share the details of it. But yeah, it's a very simple book. You don't have to have any like technical knowledge to begin with. You can, even if you find some terms or technologies, you can just Google them. So yeah. Now coming back to the topic. So as we saw earlier, right, we have some sources here. We are extracting the data. We are transforming it, and then we are basically serving the data. Same thing here, nothing different. So it's just generalized way of saying, okay, we have some sources that we generate data at. So this is where your full stack full stack app engineers work, right? Right, they will create applications that generate or capture a lot of data. This is where your generation aspect comes into picture. Ingestion, transformation, serving, this is where your data engineers come in. Data engineers plus data analysts, right? And this is where your ML people, BI people, this is reverse ETL. It's a slightly different thing, I'll explain. And this one, right? Now when it comes to like creating this system, we need some undercurrents. That means we are dependent on some important aspects that might not be visible on our day-to-day activities, but they are very important, like security. If you miss on security, right, then the whole thing is a moot point. Like it doesn't matter at all. The second thing is data management. How is your strategy? Like, if the data is always going to increase, right? On maybe not an exponential but it will definitely increase on some linear fashion, even for that matter. So how do you do that? How do you store the data efficiently? How do you not get hundreds of millions of dollars in cloud bills or in infrastructure bills, and safely store the data, retrieve the data as and when we want, and give that data ops? How do you change your pipelines? All of these architecture, orchestration, software engineering aspects. These are all present in this one. So why do we need data engineering lifecycle? Is this is how we do things in data. That's it. As simple as a sentence as I could say. This is how we do things in data. Even let's say I want to build an LLM chatbot, right? I need to scrape the internet first. Internet is my like place where I find lot of data, like through websites. People have written a lot of text over the years since 1900s, and it's all on websites. So I'll go to every single website and I will scrape this data. Okay, I'll ingest into my cloud warehouse, and I will start transforming the data. I will apply machine learning models, training, inference, and all of that, and then I will serve that as a chatbot. Okay, continuously I will do this. This data engineering life cycle, right? This data life cycle basically. So we will do this continuously. This is how intelligent systems are built in the past, the present, and the future as well. Any doubts? Okay, so now, since we are seeing this as very important, right, we will discuss this at length in these sessions. Not just theoretically, we will use tools to understand what we are doing here, right? That is what these sessions are for. And yeah. So I've written here, LLMs, agentic AI, intelligent, context aware systems. I'll explain it briefly. So what these systems are? LLMs, we have used, everyone has used. So this is the like one of the future, aspects that we are heavily relying on right now. So we want to build or use systems like ChatGPT or Claude or Gemini for anything and everything at this point. So data engineering, proves to be one of the most important, um, pillars of creating these intelligent systems. Basically, these LLMs. LLMs basically means large language models. Okay. So anytime I'll not use the term ChatGPT, Claude, or Gemini. I'll just say LLMs. I know that covers everything. So agentic AI, that means you give a goal to the certain agent, and you will give prompts, right? Prompts meaning your inputs. Let's say you want to like I know get some output from a website like booking.com, and see what all the flights that are available as per your certain requirements for the travel. So agent can go to that website, look for the flights, and get back to you with the results. So all of this will be present in the goal and in your prompts. Basically, prompts means in English, or just natural language, instructions that are given to a model. So that can be turned into a agent, basically, to provide a particular information to you back, or do certain action there. So RAG search is basically retrieval argument generator or generation. So you have these models, right? Like Claude, Gemini, or ChatGPT. These are trained on internet data. But if you have some docs on your company internal system or your personal docs, right? You cannot train the model on these data. So that's where RAG comes into picture. RAG will essentially let you upload, or let you use your docs, and then use these models to search what you want from these docs. Docs meaning any internal, data sets, or, just like Word documents, or, any documents, basically anything that has information in it, you can search it. Excuse me. So all of these need data. Excuse me. All of these need data. All of these need standardization of the processes. All of these need, lots and lots and lots of processes, security requirements and whatnot. So they all rely on something that is tried and tested, which is our data engineering lifecycle, and data engineers will be responsible for it, right? So the last thing is intelligent context aware systems. So these are combination of, ChatGPT, agentic AI, plus, lots and lots of metadata of the systems. Let's say you are building a ticket booking app, right? And it uses agentic AI. So you have to provide a lot of business context to that particular, agent. You have to, understand the user prompts, and you have to, like, make decisions on the feet without breaking the system, or without, causing any security issue. So these are, context aware systems. We are, building our, data systems towards this goal right now. So this requires a lot of data. This requires a lot of compliance, governance, all of these aspects. And this is where we are heading right now as an industry. Okay, questions?
Yeah, I'm good, Manikant.
Okay, got it. So the last thing, what do we need as skill sets, right? So now, anytime you talk about data, right, you have to have, SQL as your skill set. No questions asked. Like, you definitely need to have SQL skill set. What skill set we will discuss a little bit later on, like, in next upcoming sessions. Right? SQL is the language of data. This is language of data, right? So anytime you want to, like, query a database, you want to query a data lake, you want to query a table in a data warehouse, or even JSON documents for that matter in any data warehouse, right? You can use SQL for it. I can safely say 80 to 90% of the, like, data, engineering pipelines can be done with the help of SQL, at least the logic part of it, right? We can do it in SQL to the most part, and it is as efficient as any programming language that you can see, unless we, want some custom way of, doing things. That is when languages like Python, come into picture, right? Python is the language of, second language of data, is what I I can say, right? Because Python has a fantastic support of all, data standard libraries. Let's say you want to, build, a backend. Okay, Python has libraries for it. Suppose you want to build ML models, on a smaller scale, or even larger scale for that matter. Yes, Python has support for it. I want to build complete data engineering platforms. Yes, Python can do it. I want to build, visualizations. Yes, it can do it again. So Python has fantastic support for data and data libraries, and, anything that you want to do in data. And it's a simple language. The syntax is not that, scary or heavy, and you will get, fantastic, like, support from the community as well. So yeah, Python is one of the best choice in your data. So I joke a lot about this one, where there are two things that are certain, that is heat death of the universe, and, Python and, SQL being the languages of data. Heat death of the universe being, like, after millions of years, the earth will vanish when the sun explodes, and that is a certain thing that will happen millions of years, not to worry now. So the Python, and, SQL, even Java for that matter, they will prevail in the data industry as long as we are in the industry. It can outgrow our careers. So that's how prevalent these two are. Okay, so these two are, like, the most important things that we can learn in, to acquire data engineering skill set, right? So now when it comes to data warehouse, right? Data warehouse is a place where you store your data across, business units, across, across the entire organization, right? If you have lots and lots of data and you want it to be organized and, scaled properly, so you need a data warehouse, right? This is true for a lot of enterprises, lots of, medium to large companies, and this will be true in the coming future as well. So they use Databricks, Snowflake, BigQuery, Amazon EMR, Postgres based, this one, Redshift. So all of these, data warehouses, right? So if you want to become a data engineer, right, or if you want to be aware of, data roles, basically, you have to know about data warehouses. So which is what we are going to do. So how we are going to like get the data, store it, and scale it is what we will discuss on data warehousing. And data modeling is how you store the data, right? How you like um, not store the data, how you model the data so that the stakeholders, like, your business intelligent people, or, your ML people, can access the data very accurately and, without costing us more. So suppose, let's say, I have orders data, right, and I have transactions data. So when we are inserting this data in our data warehouse, right, these two will be separate tables. And, if you want somebody, downstream wants these two data sets, and they belong, you know um, sorry, they are extension of one another's. Like orders need transactions, confirmation, transaction details, whether the transactions went through or not, whether the order has been, placed and, delivered or not. These two are, very much sister data sets in a lot of aspects. So if a downstream person like an ML people, or, or BI people want this data set, right, we can use a logic to create a single unified data set which has both of this data side by side. They don't have to, create a join here again and again and again every time they want to pull this data. So that will, reduce the compute costs. So this is, after you understand what business is doing and how the data is being captured, and you will model this data set into one single one. So this is where data modeling comes into picture, right? To you see the access patterns, you see the, nature of the data, and you create some, place where you want to like where you can, optimize the data sets, basically. So this is how data modeling works. On a very higher note, we will discuss about this later on, but yeah, this is how it does. So we want data modeling as well, or else our arrangement of data, our compute costs and our storage costs will just keep on increasing, and we will get less business value out of it. So optional being, you have to know about cloud, because that's where all your infrastructure is, and you have to know about, some people, some companies are, have very small data teams. That means you have to do your own DevOps pipelines to, deploy your data pipelines into production. So this is an optional one, but yeah, good to have, nice to have. Okay. So the main goal of, the whole data engineering is to serve the data as fast as these people, the ML analytics people want, and, create, unlock the business value. Suppose, let's say, I have a data set that is refreshing every day. Like, I am calculating day by days, orders worth in an e-commerce website. I own a e-commerce website, and I am checking, how many orders have been passed through, what is the, worst times for, processing an order. Let's say, my order was supposed to be, going in after a day, but it hasn't been delivered since a week. So how many orders are like this? These things will show the business that something is going wrong, and that is where the business needs to work on. So how is that happening? So these are all, very important things that a business need to track, and they will track this, right? So for that, they need a lot of data. So then, it is not just for, fancy, creating some, nobody knows data sets or nobody sees their dashboards. These have real world impact. Suppose you are delayed some order on Amazon, right? You will be furious at them. If Amazon doesn't have any record of your data or your order, you will feel, betrayed, right? And you will never order on Amazon. Or, Amazon is just a placeholder example here, or any e-commerce website, basically, right? So we need data to function in this real world. That is the reality of it. And the data engineering role is the one that facilitates all of this, right? And we want to get this data as quickly as possible towards the other side, right? We want, efficient models of how we ingest, transform, and serve the data, and how we serve at scale, even though the data size and the variety of the data is increasing, ever increasing, basically, right? Okay. So any doubts? I'll stop the recording now.
Yeah, Manikant. So just want to understand how do
Mhm.
you decide whether to go for
Hmm.
SQL or Python? Like any
Okay.
situation
There
you.
is no or. There
Yeah,
is no or.
yeah.
There is only and. Okay. SQL and Python. But if I have to tell which is important as a beginning step, let's say I'm, beginning, I'm trying to, like, see myself as a data engineer now. So what is the first skill that I want to learn? Or a data professional, basically. What is the first skill that I want to learn? Simple answer, one word answer, SQL.
Okay.
Okay. Any role that you see here, right? Any role that you see here, okay, they use SQL heavily in their role, in their day-to-day jobs. Heavily, like heavily. My life is, dependent on SQL. If tomorrow SQL vanishes, right, I am done. I am done as a data engineer. Okay, that is how important SQL is. So SQL, even though it is a beautiful language, even though it has its own, like, good and bad about it, you cannot do everything, in SQL, right? You cannot connect your, like, you cannot read, data, or at least efficiently, or, like, read data from SFTP, read data from, like, JSON files, or, apply custom logic, all of that things that will not be possible or readily possible in SQL. You can do it, but you have to do mental gymnastics a lot. So Python has fantastic ecosystem there. So that is where Python comes into picture. Let's say I want to, like, get data from 20 different, sources. I can create a framework and standardize the things and say, okay, for the APIs, okay, this is where you extract the data and this is where you dump the data. And, Python will transform the data later on, or you can give it to SQL, basically, right? So I can create a framework, I can create in infrastructure with Python, and then I can just use SQL to, like, do the heavy lifting for loading, transforming the data. Okay.
Got it.
Right. So this is the place of SQL and Python. Right. So both of these run on your data warehouse. Okay. Or your data infrastructure, basically. Data warehouse is part of your data infrastructure. Am I making sense?
Yeah, got it. Got it.
Okay, yeah. So that is how it is. We will discuss at length on these topics, okay? Like at length, like excruciating details on these topics. Yeah. So that's what I want to do with these sessions. Okay, let me stop the recording now.